Welcome to MRL. In this learning session, which is the second part of learning of similarity of triangles, we'll learn the proof of corollary of BPT, which we already learned in the previous learning session, and also we'll learn the different criteria for the triangles to be similar and their proof. Now let us begin with the corollary of BPT. Now what was the statement which we had learnt earlier? The statement is, if a straight line is drawn parallel to one side of a triangle, a new triangle is formed and is known as intercepted triangle. The sides of the intercepted triangle will be in proportion to the sides of the given triangle. So let us understand this statement. Now we are given a triangle ABC. There is a triangle ABC. D is drawn parallel to BC. Then a new triangle ADE is formed, and this triangle ADE is called as intercepted triangle. Now the sides of this intercepted triangle and the sides of the given triangle ABC are in proportion. So that is what is the statement. Now let us learn how to explain and prove this statement. Now we are given a triangle ABC, D is parallel to BC, intercepted triangle ADE is formed. Now we have to prove that AD upon AB is equal to AE upon AC and is equal to D upon BC. So that is what we have to prove. Now let us draw a line FE or EF parallel to DB, EF parallel to DB or EF parallel to AB. Then BFED is a parallelogram formed because opposite sides are parallel here, because we have BD parallel to FE and BF parallel to DE, therefore it is a parallelogram. And in a parallelogram the opposite sides are equal, that is BF is equal to DE and BD is equal to FE. Now let us consider the triangle ABC. Let us take the triangle ABC. In triangle ABC, D is parallel to BC, which is given to us. D is parallel to BC. If D is parallel to BC, then AD upon BD is equal to AE upon CE by BPT. Now we can write the other form of BPT, that is AD upon AB is equal to AE upon AC. That is AE upon AC, that is the other form of BPT which we have already learnt. Now also FE is parallel to AB. This FE is parallel to BA or EF is parallel to AB. That means BF upon CF is equal to AE upon CE. BF upon CF is equal to E upon CE by BPT. By writing the other form of BPT, we have BF upon BC is equal to AE upon AC. And that is 1, the other one is 2. So comparing 1 and 2, we have AE and AC are the same on RHS. Therefore, we can equate BF upon BC is equal to BF upon BC is equal to AD upon AB. Therefore, AD upon AB is equal to AE upon AC is equal to D is equal to BF upon BC. So all three can be equated. But we know that BF and DE are equal because they are opposite sides of parallelogram. So replacing BF by DE, we get AD upon AB is equal to AE upon AC is equal to DE upon BC, and that is what is the required proof. So that is how we explain the proof of this particular corollary of BPT. Remember that. Now we will discuss the AAA similarity criteria of triangles. Now AAA similarity of criteria of triangle states, if two triangles are equiangular, then they are similar. That means if two triangles are equiangular, then their corresponding sides are proportional and the triangles are similar. Please understand the statement here. If two triangles are equiangular, but definitely their corresponding sides are proportional and therefore the two triangles are similar. So now to prove this criteria, we have to just show that the corresponding sides of the two triangles are proportional, and if we show that they are proportional, then the two triangles are similar. Okay, let us understand this. Now we are given a triangle ABC and a triangle DEF. Angle A is equal to angle D, angle B is equal to angle E, angle C is equal to angle F, because corresponding angles are equal. They are given to us. Now we have to prove that AB upon DE is equal to BC upon AF is equal to AC upon DF, and because we are proving the second condition of criteria of triangles, that there is corresponding sides are proportional, therefore the two triangles are similar. Now we require a construction to be made here. Now mark a point P on DE such that DP and AB are equal, Again mark a point Q on DF such that DQ is equal to AC, and then join PQ. So that is the construction required. Now in triangle ABC and triangle DPQ, we know that AB is equal to DP by construction, AC is equal to DQ by construction, and angle A is equal to angle D, it is given to us. Therefore by side angle side congruency criteria, triangle ABC and triangle DPQ are congruent. If the two triangles are congruent, then the corresponding sides and angles are equal. Therefore BC is equal to PQ, angle B is equal to angle P, and but what we know is that angle B is also equal to angle E. This is given to us, and therefore we have angle P is equal to angle E. If angle P is equal to angle E, then corresponding angles are equal. Therefore PQ is parallel to EF. Remember that. Now if PQ is parallel to EF, by BPT we know that PD, that is, or DP upon P is equal to DQ upon QF. DP upon P is equal to DQ upon QF, that is by BPT. But we have another form of BPT, that is DP upon DE is equal to DQ upon DF. Okay, DP upon D is equal to DQ upon DF. So let us call this as 1. Similarly, now instead of drawing PQ parallel to EF, we can draw PQ parallel to DE and prove that DP upon DE is equal to BC upon EF. Same way as we have proved here, same way we can prove that DP upon DE is equal to BC upon EF, and that is the second relation. Now from 1 and 2 what we get, DP upon DE is equal to DQ upon DF is equal to BC upon EF. But we know that DP is equal to AB and BC as it is BC only, DQ is equal to AC, because by construction we know that DP is equal to AB and DQ is equal to AC. So replacing them we get AB upon DE is equal to BC upon EF is equal to AC upon DF, which is which shows that the sides are the corresponding sides of the two triangles are proportional, and because the sides are proportional, the triangles are similar, and that is the proof of this particular criteria of similarity of triangles, which we call it as a triple A similarity criteria, or even we can call it as a double A similarity criteria. So please remember this, a very important criteria and the proof of the criteria. Okay, remember that.